Good afternoon and welcome to NASA's Kennedy Space Center. We are here today for the SpaceX Demo-1 mission pre-launch news conference with NASA managers and SpaceX managers, as well as someone from the 45th Space Wing. Let me introduce today's panelists. We have Kathy Leaders, NASA Commercial Crew Program Manager here at NASA's Kennedy Space Center. We have Hans Königsmann, Vice President of Build and Flight Reliability with SpaceX. Joel Montalbano, Deputy Manager for the International Space Station Program located at Johnson Space Center. Pat Forrester, the Chief of the Astronaut Office at NASA's Johnson Space Center. And Melody Levin, the Launch Weather Officer for the 45th Weather Squadron. We will begin with opening remarks from our panel here in the room, and then we will open it up for questions. Once we answer some questions here in the room, we will take questions from the phone bridge. And if you're at home following along, you can send in your questions on social media using the hashtag AskNASA. I'd like to open it up with Kathy.
Thank you, Stephanie. Thank you for coming. This is a big day for us, obviously. We're getting ready to go fly our first uncrewed mission with what will be our crewed design of the SpaceX Dragon. And I have a little video here. Of course, we have to have a video. Here we are, we're NASA, first one out. It's going to show how important this flight test is for us from a learning perspective. So can we play the video?
So we're going to have an orbital flight test, a test without the crew in it of each vehicle, and then we're going to have the first flight with crew in them to prove that these systems are ready to fly people to space.
These demonstration missions are important for astronaut safety because, the folks around here that I work with, we all ask ourselves, would we be comfortable flying our own family on board this vehicle? And the answer has to be yes. And so because of that, we need to make sure we test these as much as we can.
Since we're dealing sort of with a new generation of people who are putting human space vehicles together again, I think it's important to impress upon them every day that there is not a day where their attention can waver.
We can test them down here on Earth. We can put them in vacuum chambers and acoustic chambers and do thermal tests on them, but there's nothing like going up and putting them in the real environment.
That will give us a lot of insight on the vehicle performance, the functional systems, even the abort system will be active on that vehicle.
So that's why these initial test flights are so important, is because you need to see it's not just the hardware, it's also the software, it's the people, it's the procedures, it's the whole thing coming together.
Boeing's supposed to land on land, SpaceX is supposed to land in water. Those are two hugely different environments, so there's a little bit of interest in the survival equipment that's located in the spacecraft as well, where that's going to be, how that's going to work.
This is a really critical aspect of the NASA job, is to continue to have that dialogue with the contractors about, well, why did you do that? Why was that safer?
This is someone's family member, husband, wife, uncle, aunt. It's not an option to not be successful. We have to be successful.
So this mission will be, if you can run the first slide. There's some really key objectives. Hans will be talking a little bit more about some of the work that SpaceX has been doing getting ready, but from a NASA perspective, we're really wanting to see the on-orbit performance, how the systems are going to be working together. The key, obviously, avionics, docking, making sure common telemetry with the International Space Station and the ground is working properly. And then we're going to be learning from the ECLSS systems and the power systems, solar arrays and electrical power systems. It's really power generation on orbit and how all of our estimates on power budget and how the system's working are really, really critical. Like the folks were saying in the video, this is a invaluable exercise for us to learn in the space environment how these systems will be working, and then making sure that these systems are ready to go for when we're going to put our crews on them. And then, there's their launch escape system will be in monitor mode, so that's really important because for the next mission, obviously we need to have our key abort systems working, and so it's important to be able to go take those parameters then and make sure that those parameters are appropriate then for us to ensure that the systems are going to be functioning when we need them to function, and are set properly. And then, the part that we don't talk about often is we talk about the hardware and the software, but we don't talk about the people systems. And it's really us figuring out how to operate together and work together so that the next time when we're working together to fly our crews, we can do that in a safe and efficient manner. Hans and I feel like we've been going through reviews for the last few weeks, maybe weeks of reviews, but that's all really important for us to go figure out how we need to work this for when it's our crewed missions. Next slide. So I really appreciate it. We have a quick timeline is that, we're getting ready obviously for a launch at early in the morning on Saturday morning, and looking at then docking about 27 hours later with a 5-day mission, and then re-entry and splashdown on the 5th day. Obviously, we're going to have to be working together and learning from this experience as we go through the whole demonstration mission and making sure that each aspect of the systems that we'll be trying out will be then applied to our crewed missions and making sure that those systems are as safe as possible. So thank you for coming and showing your interest in this for us, which is a huge day for our program.
Thank you, Kathy. We'll know. Hans?
Thanks, Kathy. Yeah, we're targeting 2:49 on a Saturday morning, early in the morning. This is the East Coast time here. And we're targeting that time for the first launch of the Crew Dragon to the International Space Station. There's a backup launch opportunity on Tuesday, March 5, an hour earlier, but also in the middle of the night, in case we have weather or some other issues on Saturday morning. SpaceX learned a lot over the past 70 missions and the past 16 Dragon missions, and everything we learned, everything we experience is basically in this particular Dragon version and in this particular mission. We've done an incredible amount of testing together with NASA and made sure that everything is safe and ready to go. And I do have a small video too, just to stay on topic. Okay, this is the whole stack, Falcon 9 and Dragon on top. This is Dragon naked and dressed. This is really fast. This is the acoustic test. Here's the docking test, and you can see the docking mechanism. Yeah, there it goes. This is the EMI test. I see an antenna going around and basically measuring the emissions. This is a hover test that's been a while ago, exercising the Super Dracos that are also a launch escape system. That's the nose cone deploy test. It's fast. Mission control. And here we go to the human interface. This is the control panels there and our 2 astronauts. This hit-drop test with a parachute. You can see there's actually 4 parachutes as opposed to 3 on Dragon 1. And here's the crew access arm, which connects the tower with the Falcon 9 and Dragon launch vehicle, and this was really fast. I'm sorry, I had to speed this up. I wish I could make this a little bit slower, but I hope you got everything, all the technical details that I talked about. The Dragon will be deployed about 11 minutes. Actually, I have a slide on that one too about the timeline. Maybe I can do that. Well, I talked about the launch time already, 2:49. It's our first launch from LC-39A, and we do attempt to recover the first stage on the drone ship. Next one, please. All right. So this is the timeline of the launch itself. We start out basically with a call on 45 minutes before launch. The first thing we do is we arm the launch escape system, and that is to keep Dragon and later the crew safe actually before there's propellant on board, and the entire time while we're actually loading it. It's very important. There's also nobody on the launch pad anymore at that time. At 45 minutes before launch, we start loading RP1 on both first and second stage. We then start loading LOX on the first stage right around the same time, I think, actually. The second stage always amazes me because we start loading at T-minus 16 minutes, and it is relatively fast, but you got to keep in mind we actually empty the tank even faster in a couple of minutes when we run it through the engine, so it's actually not that fast in perspective. Well, we begin chilling all the engines prior to launch at about 7 minutes before that. We transition Dragon into internal power, 5 minutes. A minute before launch, we do the vehicle goes into a computer-controlled mode, and we begin pressurizing the tanks on the Falcon 9. And then at 45 seconds, we have the LD, the launch director, confirm that we're still good to go with the range at NASA. And then at T-minus 3 seconds, we start spinning up the engines, and then at T0 is liftoff. Next one, please. In flight itself, it's somewhat similar to other launches, but I still want to repeat a little bit what we do. Around a minute into flight, you have max Q. That's basically the maximum dynamic pressure that the vehicle sees. 2.5 minutes into flight, we have cutoff, main engine cutoff on the first stage, followed by stage separation, engine start, and then the second stage is on its way, while the first stage actually performs an entry burn around 7 minutes after launch. The second stage engine cutoff is roughly 9 minutes, I think. Yes, 9 minutes. And actually before we land the first stage, stage itself lands 9.5 minutes after T0, actually close to 10. And then Dragon, as I mentioned, separates 11 minutes after launch and goes on its journey on its own. Dragon will perform 3 burns and approach the station within roughly 30 hours. We expect docking to happen on early, Sunday morning, then at 6 a.m. That's roughly the time frame. I know you're going to talk about that a little bit more. So, the Dragon will be on station for a couple of days. We are planning to depart the station on March 8. And then it will perform a couple orbits, about 5 hours, and then perform an entry burn, re-entry burn rather, and land actually in the Atlantic. That is different from Dragon 1, which always landed in the Pacific. It takes about 35-40 minutes after the burn to get through the atmosphere, deploy the 2 drogues and the 4 main chutes, and then land safely in the water and get picked up by a boat on standby in the area. And that obviously is something that we have to practice in preparation for actually crew flight, make sure that we are fast on the right spot, that we have all the potential medical attention at the right time, and so that's going to be exciting for us to get everything. This is a very important training for us to get this right for the crew flight coming up next. The task ahead of us is really historic. I really want to thank NASA for the opportunity, and thank you very much on behalf of all SpaceX employees. Also now our teams worked really hard on this. Shout out to the Dragon team and also the Falcon team that did great work over the past actually years. And particular in the last couple of months, working through an incredible amount of detailed issues, making sure the capsule is safe to fly.
And you know what? I have a surprise for you, Hans.
You do?
So I think we have a picture of rollout or video. You want to show that?
Ah.
There it is.
Yeah,
Getting ready.
I'm actually, I came from the pad on the way up here,
Oh,
and
okay,
I looked at it. so
That's kind of anticlimactic for you.
we actually went up the tower, and I was really impressed. I mean, everything is in top condition. Everything is freshly painted. It looks great. I'm really amazed by what this team did in the past couple of weeks, and I'm pretty sure we're going to see a great launch and a great mission.
Yep.
So I'm really optimistic.
Joel.
All right, well, welcome again to the Demo-1 launch, pre-launch briefing. Kathy and Hans have talked about all the work that's been done to get us here. It's been a journey, just an incredible amount of work, an incredible amount of team effort. You know, we take a fully functional International Space Station program with crews going up and down, doing daily science and research on board. We bring in a commercial crew program that brings in 2 providers that'll be docking vehicles to the International Space Station. We integrate all that work with our international partners, and it's just an incredible task, and it brings an excitement back to KSC that we haven't seen in a while. I mean, you can just tell by this last month when people are we're ready. You know, they're looking forward to launch this weekend, and today we sit at L-2 with a vehicle at the launch pad, a vehicle that eventually will bring crew members, like we said, this one uncrewed, but eventually we'll be bringing crew members to the International Space Station, and it's just a pleasure to be there. On orbit, the crew has checked out the interface, the docking interface. The docking interface looks good. It's a robotic checkout we do. We're also doing other things on board, checking out cameras, clearing the port where they'll be going, make sure there's no stowage there for the vehicle as they come in. And once you open the hatches, everything is good to go. And again, this is just the first event in March. Just 2 weeks later, we'll have a Soyuz launch out of Baikonur, Kazakhstan. We'll be bringing 3 more crew members, getting us back to the nominal 6 crew members on board the International Space Station. And we'll stay in that configuration with 6 crew until the summer. With that, I'd like to show a video of the crew we have on orbit.
And liftoff. We have liftoff.
So launched in early December, 3 crew members. Obviously on the Soyuz spacecraft out of Baikonur. You see just a beautiful picture of the International Space Station and the approach, the welcome crew. Here is an experiment called Spheres. This is an awesome experiment. High school students are selected to design algorithms for these 2 to do docking testing on orbit. And we use this for other explorations in space, other spacecraft. Here you see the crew members working on the robotic refueling mission tool hardware. And so this is hardware that was flown inside the International Space Station. It'll be put on the Japanese slide table that'll go outside the International Space Station. And it's a test on how we refuel satellites. Now this is some older video of an earlier part of this mission, the refueling mission number 2. You see where we were installing an interface there. You see some little water droplets. Refueling spacecraft is something that we're doing testing on the International Space Station, and that's going to play forward to other science and other experiments and other satellites, and give us the ability to refuel satellites. You see here an exploration project where we're taking pictures of the moon, and we'll be actually using the moon for some navigational techniques with the Orion spacecraft. Here you see the SpaceX 16 mission that was launched and then birthed to the International Space Station. You thought Hans's video was fast. I figured I can top that. So just the crew doing some stowage activities. You saw a little picture of Valentine's Day with the crew doing the little hearts. And then here you have a bone marrow experiment. And what's interesting on the bone marrow experiment is you can apply that to people who are in bed rest on Earth. So we're doing experiments on board the International Space Station that directly applies to people here on Earth. So with that, that video shows you 3 crew members that are extremely happy. It's a pleasure to see the smiles on their face, to watch them on a daily basis. It's good to have another Canadian astronaut on board along with our other crew members. Just today there was, you probably heard, a press brief with the Prime Minister of Canada where they announced that they'll be joining the Gateway Exploration Program. And, you know, we're using space station today to test exploration techniques, to do science and do research. And we're using it to leave, you know, eventually we'll leave low Earth orbit. And what we learned today on space station is going to apply. So with that, I want to thank you again, and I'll hand it over to Pat.
Great. Thanks, Joel. First of all, I got to tell you, it's great to be back at Kennedy Space Center. And it's not just because of the fine people and the exceptional facilities. It's because this is where I left planet Earth each time I went to space. And the prospect of being part of the process that will allow our current and future astronauts to do that again is pretty exciting for me. It'll be more exciting when we come back for DM2, when we could put Bob Behnken and Doug Hurley on top of that rocket for their test mission. But even though a lot of progress has been made, there's still a lot of work that we need to do. And we're looking forward to working as a team with SpaceX to get that done. The launch early in the morning on Saturday is definitely a milestone. There's another milestone, and we've touched on it a little bit, and that's on Sunday when this thing docks to the International Space Station. Because although we don't have any astronauts on DM-1, we do have them on the space station. Joel showed you a great video of them. We have 3 of them, NASA astronaut, Army Lieutenant Colonel Ann McClain, CSA astronaut David St. Jacques, and the Russian cosmonaut Oleg Kononenko. And they have been preparing and training to receive this vehicle. And it also helps us to remind the risk that's involved. Despite the fact that there's no one launching, there is always human life at risk. And so we want to stay focused, and we want to stay vigilant, and we want to continue to move down this path that we've started. I heard from Ann just before coming over here to the press site, and to echo her words, she is humbled and feels privileged to have a front row seat to this historic event. They are looking forward to what all SpaceX can do and where we go with commercial crew as we bring more crew members aboard. And just as you saw, there's 3 up there now. In 2 short weeks, we'll be over in Kazakhstan with the Russians launching another crew of 3. And that's typically what we've had up there most of the time is 6 people. And once we start regular flying crew on commercial crew, we're going to have the ability to have 7 crew members up there. And that may not seem like a big jump, but statistics tell us that having 1 more crew member up there, we can almost double the science and the research that's being done. Think about being at home. There's a lot of maintenance that's required on the space station. There's a lot of maintenance required around your house. How many times have you thought, if I just had 1 more set of hands, I could get ahead. I could get what I need done. So we're looking forward to moving that direction. And again, it's a privilege to be here.
Thank you, Pat. Melody.
Good afternoon. Well, if you haven't heard already, I have some pretty good news to share as far as the weather goes during the launch window early Saturday morning. Looks pretty good. Let's go ahead and go to infrared imagery. There we go. First, I want to explain a little bit. When you look at the satellite imagery, you're looking at an infrared image. The colder the cloud tops, the higher the storms, essentially. So when you see yellows and reds, those are higher cloud tops. Right now, we do actually have a pretty minor disturbance located across the Florida Panhandle, and it's slowly shifting to the east, and that shift is going to continue overnight tonight and into tomorrow morning. And all it really is going to do is send us some cloud cover across the area, arriving late tonight, and it's going to linger for much of the day tomorrow. But the good news is we should have high pressure building from south to north across the Florida Peninsula. It's a pretty weak high pressure, but it's going to be just enough to clear our clouds out of the way in time for the launch window around 2:48 a.m. And we'll go to the next slide. So here is the forecast for your launch, your primary launch window on early Saturday morning. We're going for a pretty light west-southwesterly wind. At the surface, it'll be much lighter than that, but up at 200 feet where the rocket extends to. We're expecting 10 to 15 miles per hour, a comfortable 65 degrees. The only concerns we have are with the thick cloud rule and the cumulus cloud rule for perhaps any lingering cloud cover that didn't clear out on time. We're going an 80% go for launch. And for the backup window, let's go to the next slide. Okay, now the delay window is actually 72 hours after, so we're looking at really early Tuesday morning for this. So this isn't, because this is more in the future, it's a little bit harder to nail down what the weather is going to be, just because models diverge a lot as we get into the future. But right now we're actually pretty confident that there's going to be a frontal boundary generally within the vicinity of the Space Coast during this time. And because of that, our probabilities are a little bit more pessimistic. We're only going about 60% go for launch. Our primary concerns are flight through precipitation during this scenario, but we also continue to have concerns with the cumulus and the thick cloud rules during that time. Our winds do still look to be pretty light, though, during that time out of the north-northeast, 10 to 15 miles per hour, with a temperature of 62 degrees. And that is all I have for you. Enjoy the launch.
We will now take questions from those of you in the room. To ensure that everyone has a possibility of trying to ask a question, we ask that everyone keeps it to one question only. When I call on you, please state your name and affiliation and to whom you're addressing your question. So we'll start with Marcia.
Marcia Dunn, Associated Press for Hans. You used the word historic. Could you talk about, this is all brand new territory for SpaceX. Could you talk about what this means to the team, your team, and the emotions that are going on right now? And I'm also wondering if since last Friday you've gotten wind of the Dragon Rider's name.
About the what?
The Dragon Rider's name, the mannequin's name.
Oh yeah, good. Yes. Yeah, I mean, SpaceX was early on. Our goal was human spaceflight, and obviously towards Mars. So the human spaceflight part is a core value business of SpaceX, and so and we've been working on developing rockets and spacecraft for, I guess, close to 17 years by now, and this is basically for the team. It's a combination of what we were founded for to some extent. Yeah, I mean, this is what we wanted to do. Early Dragon 1 had a window on the side, and this was clearly a hint to everybody. We want to fly humans into space, and we want to do this. This is our goal. This is why we're actually there. So clearly super important for us, and incredible. I guess both important and important that we do this and get it done right and continue then flying more and more human missions over the next couple of years. I'm actually humbled by being at that point after almost 17 years of working this. It's pretty amazing to do this. And with respect to the, well, I said dummy. It's actually a Smarty, right? It has lots of sensors, so we call it a Smarty. And her name is Ripley. Her name is Ripley. Yes. Alien.
Let's go to Bill Harwood.
Bill Harwood, CBS. Pat, since you're here representing the crew office, can you maybe give us a little perspective? Hans mentioned the flight termination system gets activated at 37 minutes. And load and go, of course, is something totally unique to SpaceX when it comes to human spaceflight. So can you maybe give us the crew's perspective on putting the astronauts on board before fueling, in the wake of the COPV problems in the past and all of that, and the flight termination system, how comfortable you guys are with that whole sequence?
Well, obviously, the safety of our crew is most important to us, and working with SpaceX, understanding this process and the reason they do it and how they do it, we came to the conclusion that this was an acceptable risk that we were willing to take. I can turn it over to Kathy if I need to, but we got comfortable with it. We would not be doing it if it was not what we had agreed to.
Anything specific?
Can I correct one term? The term flight termination means something else. You're talking about the launch escape system. very, very different. The flight termination system, a traditional one, stops the rocket, and the launch escape is actually the one that saves the astronaut.
I'm sorry, but that's what I meant. I appreciate it. Well, I'll just leave it at that then. What the heck?
Irene.
Thanks. Irene Klotz with Aviation Week. Maybe for Joel, what was the resolution of the issue that the Russians had with the Dragon flight computer not having a backup or a separate box for approach? And also, if there were any variances that needed to be granted for this flight, I guess that would be for Kathy. Thanks.
I'll take the first question. So we agreed with Roscosmos yesterday on a protocol of the approach. Actually, through discussions with them, explaining the steps that SpaceX has taken in order to ensure the safety, they asked for some additional steps. What would happen, even though it's a very remote case, what would happen if it were to happen? And they wanted us to take some steps where we would protect the space station, close another hatch or two, have the Soyuz, have the crew ready to go with the Soyuz. We agreed to do that. We worked that with the crew. And if you were to have this very remote failure, so everything's working fine, we also have, we have gates throughout the profile that says the spacecraft has to meet these gates in order to go forward. So this would be everything is still working, and then you would have this failure that they're worried about, then we would take these extra measures. But they're agreeing with that. The flight control teams are working with that. They're finalizing the procedures today, and they agreed and concurred. They signed the protocol to concur with the launch and docking.
So there's really two sets of requirements that govern this mission. The most important set really is the 508, what we call the 50808, which is the visiting vehicle requirement set that stations defined for all vehicles coming to the International Space Station. All vehicles have variances to those requirements because they're tailored for particular vehicles. But I'll tell you, Irene, both programs have gone through and assessed the variances and accepted it. And like Kirk talked about last Friday, we understand the risks and have accepted them and closed them out for these flights.
Can you be any more specific?
I mean, we can. I don't have the whole list of variances off the top of my head, but I mean, there's always tailoring that's involved, and there's always specific limits for each system. But overall, there's no compromise on the ISS crew safety and assessment of that. So all of our basic requirements have to be met from a crew safety perspective and assessed with the tailoring and the risk acceptance in each of those statements. I can't give you, off the top of my head, all the variances. I'd be a very smart program manager, and I need to work on that a little bit more. So.
Okay, Chris. Directly behind Chris Davenport.
Hi, Chris Davenport from the Washington Post. For Hans or Kathy, I guess. At the briefing on Friday, Gerst had talked about some problem with the thrusters on the Dragon, and I didn't quite understand what the problem was or how you're going to mitigate that for this flight, because that was the first time I'd heard about that. I wonder if you could just understand that maybe a little bit better.
Well, I think I can talk about it a little bit because we've been working as a joint team on it. I think there was, we always learn about the vehicles, and the SpaceX folks had gone through thermovac testing last summer, and obviously as you understand thermally how the vehicle is going to operate during the regime, they were applying that thermal environment then to their Draco testing, and ended up finding out that for the full environment that we were expecting this mission to be originally operated within, the Dracos didn't like that environment. They weren't operating that well within that environment. So actually what NASA and SpaceX have done and worked together on is developing a operational mission that constrains the operating temperature that those thrusters then have to work within, and to be able to safely accomplish the mission. So it's another place you learn while we're doing our integrated testing. We're taking that learning and we'll apply that learning to the crewed Dragon, and we'll be applying heaters to the lines and doing different things to make sure that for the DM2 mission, we're not having to constrain the mission in the same way. Hopefully we explained it a little bit better the second time around. Sorry.
Question right here. Ken Kramer.
Hi, thanks. Ken Kramer for Space Up Close Rocket STEM. First, good luck on everything. It is a very exciting day, like you said. For Hans, my question is, can you tell us how close the Demo-2 is going to be to this Demo-1? Are all the systems the same, especially life support, or are there some systems you still need to work on and add for the Demo-2 capsule? Thanks.
Yeah, I would say the systems are very similar, but there's still some work to be done. You mentioned life support. The system on Demo-2 is slightly bigger for bigger size, basically, yeah. But it's the same components, for example. The majority of the components flying on Demo-1 is going to be exactly the same. But then again, for example, the certain software will be continued to be developed, and certain tests that are currently in the works will be, like on the heater system, is that also obviously needs to be tested and then verify that it actually does the job properly. So there's I would say a lot of detail that we have to work through, but in general that is the same vehicle overall.
I think there's two drivers. One was, what's the goal of the uncrewed mission? So we talked about the objectives, right? So because this is it's not reused, we worked with SpaceX on which parts of the system should be on board because we don't have a crew on board, right? So what part of the ecosystem do we need to have on board to be able to collect the data to make sure that we can then use that data to apply to the next mission? And so that's kind of the one difference. And then the other difference is obviously if we found things late in testing that we want to change and improve on for DM2, obviously, we're working and SpaceX is working to make the DM2 vehicle better. So there's really two categories of differences between DM1 and DM2. The stuff that we didn't need because it's not crewed, you don't need obviously crew interfaces unless Ripley's going to start flying the vehicle, which I don't think is going to happen, right? And then the second piece is the stuff that we found in the last 6 to 9 months that the capsule have been basically done, but we're applying that learning to the DM2 vehicle.
And looking forward, obviously, this is a test flight, so we will learn things and we will gather experience with our subsystems, and we might find something that might have to be applied for Demo-2.
Right.
So that I wouldn't be surprised if that happens. We'll see how it goes.
But any changes you might need to make, you could still think you would make the July target?
Depends a little bit on how it goes, but if we find, there's really a lot of ingenuity in both teams here. Yeah? For example, that thruster thing that we found, I think the solution is really great, and we worked this through in a relatively short time. So if it's something similar like that, I would expect us to find a similar operational solution here.
Okay, we'll take one last question in the room before going to the phone bridge.
Hi, Jeff Faust of Space News. For Hans, can you talk a little bit about how the approach of Crew Dragon to ISS is going to be different from the Cargo Dragon? Obviously, it's a docking, not a berthing, but what's the approach going to be like for the spacecraft?
It's a great question, actually. So there's two different approaches, or two fundamentally different approaches to the ISS. One is the Arbor, and then the other one is the VBER. I guess it's radial and velocity. And the Dragon 1 was climbing up the Arbor and hovering basically under the ISS. And I showed a video last time trying to to demonstrate that because you can really see on how it actually moves back and forth in its box, and then the arm comes and grabs it and moves it over to a birthing port. This one, however, is different. This one is active in a way that it will it will climb up in front of the station and then approach the station from the velocity vector and use a docking port on its own. There's no arm required, which is a little bit. I guess for the overall mission, less parts are needed, so it's a little bit more reliable when it's worked out. And on the other side, it's a very different dynamic approach than the Arbor and the V-bar. You basically have to actively, I guess, accelerate and brake to get towards the station. Versus on the Arbor, if you do nothing, you would slowly fall away and move away from the station. So it's a different philosophy. I guess at the end of the day, we will use all different methods for human spaceflight here, and so that for us it's an extension of our capabilities.
And on the approach, the vehicle will come into about 150 meters. On the V-bar, as it comes a little closer, the crews will test a retreat command. The vehicle will move back out to about 180 meters or so, sit there for about 10 minutes. And this is all part of the testing we do to ensure the safety of the space station. Then it'll be commanded in. It'll do one more stop at about 20 meters for a little bit. Again, just do some testing, make sure everything is good to go, and then come in for docking. So this is a profile. We've worked with SpaceX, and we're comfortable as the International Space Station accepting this vehicle.
So we're going to go to the phone, and we have Eric Berger with Ars Technica.
The plans for hatch opening on station when this Dragon docks up on station, assuming everything goes well. I take it there's some kind of maybe ceremony plan or something like that?
And so right now the plan is that hatch opening will be about 2 hours and 45 minutes after docking. The first thing that we have scheduled is the crew will do some atmosphere checkout of the vehicle. And so a U.S. crew member and a Russian crew member will go inside the vehicle. They have some atmosphere monitoring hardware they'll take out. They'll bring it into the International Space Station part in the U.S. lab, do some kind of baseline calibration, go back in the vehicle, just test everything out, and then we'll continue working with the mission.
Very good. So at this point, we'll take a question from social media.
Stephen Smith on Twitter asks, how will capsule recovery operations change for SpaceX with the addition of human spaceflight?
I guess it goes to me. Fundamentally, no. I mean, it's the same water landing as it is on Dragon 1. It is a little bit more important to get closer to it, and so we have a ship on standby, and we'll get very close to the capsule, as close as it is safe. I don't think there's fundamentally a difference, in particular on this one, but this one also has all the infrastructure in place to work with astronauts coming back. So there's going to be medical and emergency, and everything is in place for this mission. Although it's more a practice run on this mission, just to make sure that we are ready for Demo-2.
Thank you. We'll take a question right here.
Hi, this is Dave Mosher with Business Insider and Insider. I think this is either for Kathy or Hans or both. Tell me a little bit more about Ripley. Someone mentioned previously that it would have sensors in it. What are those sensors looking for? What are you trying to ascertain from that? And the other half of my question is, after you get this capsule back on the ground, how long is it going to take you from a programmatic standpoint to say this was a success and here's why? Like, what does that look like?
I can try and answer your Ripley question. It's obviously sensors that measure forces, acceleration, and then the environment itself. And just the goal is to get an idea on how humans would feel in her place, basically. I don't expect actually a lot of surprises there, but it's better to verify, make sure that it's safe and everything is comfortable for our astronauts going on the next flight of the capsule. And with respect to success, I don't think we need the. I mean, this is something that will build up during the mission, and we will, during the mission, see if we can check off, certain expectations and what we wanted to test out. I see this as a continuous check, basically, during the entire mission.
I kept calling the ATD a Riley, so I'm glad you found out. It was Ripley, sorry. We're this data is pretty invaluable. So obviously there's going to be a ton of data coming down. The crew environment and seeing how the seat attenuation, how well the seats attenuate and protect the crew members and the overall vehicle is really, really critical for us, because we've done tons of water landing testing, parachute testing, all these individual pieces, but actually having a re-entry with Ripley in the seat, in the position, is critical. And then obviously all of the data from the mission. We've been working with SpaceX. Obviously we instrumented the crap out of this vehicle. I mean, it's got data, sensors everywhere, so that we can kind of go take that and then stick it in the models and assess, whether what we were predicting is accurate, and so then we can use that moving forward. We're gonna learn a ton from this mission.
So we'll go straight to the back.
Thank you. Chuck Fields, Online Coffee Break. Hans, this is for you. Last year, the video of Starman just captured the hearts and imagination around the world. Are there going to be any video cameras inside Crew Dragon, possibly aimed at Ripley? And if so, are you going to live video stream any of those during any parts of the mission?
Yeah, there will be video cameras, and there will be nice views, and it will give you a perspective that you would have if you were inside. So I'm pretty sure we will create another nice video.
Okay, so we have a question right here.
Thank you. Tarek Malik with Space.com. I think my question is for Joel. You mentioned the different mood here at the Space Center for this launch. It's been 8 years almost since the last crew-capable spacecraft did launch from the Space Center. This is kind of a shift in operations here, and I'm just kind of wondering about that milestone, how it feels from the station perspective to be at this point, and Hans, from the development. You've put so much work into the pad itself. You've flown 2 different types of rockets, now a 3rd type of spacecraft from the vehicle. Kind of what that milestone means, given that we're just 5 years after the Commercial Crew Award in 2014.
Yeah, so from my standpoint, it's exciting to be here today. Pat mentioned that with the 4th crew, we're going to double our crew-tended utilization and research on board the International Space Station. And, while we've been waiting for this, our international partners, Roscosmos has been a great partner, as well as all the other international partners in helping us get to where we are today. So to me, this is just the next step in our evolution in maximizing the utilization of the International Space Station. So from a ISS program standpoint, we're waiting for this, we're excited, we're ready, and we couldn't be happier.
Yeah, I mean, I tried to explain earlier how important this is for SpaceX, how it basically reflects what we were founded for, and so on. But also, on a personal level, this is an extremely important mission. I mean, every mission is important, but this is even more important. And I'm pretty sure, it's not just me. I think everybody within SpaceX feels this and wants to get this right and puts a lot of effort in there. Our lives are basically driven by launch dates. And this particular launch date sticks out, long ahead, as will obviously in-flight abort, and as will be Demo-2 will be. I can't even imagine how important that's going to be.
Thank you. So we'll take a question in the front.
John McGill with Wyandotte Cable and News. This is for Kathy, Hans, and Joel. If you could just talk a little bit about the bonds and trust that's formed between the 3 of you, your 3, different aspects.
I think the amazing part of this whole mission is honestly that it is about 3 partners. I mean, we would not be here where we were today if we didn't have SpaceX's ingenuity, space station's patience and the commercial crew program teams, continued endeavor to try to do things a little bit different and listen to their partners, right? And so it's really taken all three of us working together and sometimes tussling a little bit, but, figuring out really how to make this work as a team. And as a team, we're going to fly, and as a team, we're going to accomplish this mission, and it's going to be a real amazing thing.
Yeah, I mean, it's to some extent an experiment to put two organizations together that are as different as SpaceX and NASA. But, one thing we learned, actually, we're not that different in the end. We're engineers, and we want to get this done safely and in a nice, reliable solution that is robust and able to withstand, the environments. So obviously we had to get to this point where we learn from each other. And I personally, I'm convinced this made certainly SpaceX better to have NASA guide us and to look at requirements and try to question the requirements and then what's the true reason behind those requirements, and then basically comply with the overall safety culture that NASA, I guess, taught us, I would say, to some extent. And so I feel like it certainly made a better SpaceX and made better engineers out of the SpaceX engineers. And I really appreciate that very much.
And I definitely can tell you it made better NASA engineers out of the experience, too.
And to me, it's like a family. We've had the luxury of working with the SpaceX team on cargo missions and learning, how they operate. They've learned how we operate, bringing in the commercial crew program and bringing the three of us together. It's been fantastic. I mean, when you work with physics, that's the coolest thing, because physics is the same no matter where you go. And we work together. There's things where, hey, we have this requirement. Maybe we can't, get exactly what, can you help us there? And, the ISS program helps, or commercial crew program helps, or SpaceX helps. We're all given, it's pulling and pushing throughout the process. It's been incredible. You make friends. These, our engineers are calling up different people in the crew program and the SpaceX team and vice versa. And they're doing not only work stuff, but they're doing family things too. So to me, it's been fantastic.
So we have time for one last question. We'll go right here.
Hi, Robert Perlman with Collect Space. I think for Hans, can you talk a little bit about the launch control for this flight? Are you flying out of the LCC or out of the Cape Side? And what size is the team? And are you integrating NASA people into the team for this launch?
Yeah, it's an excellent question. We are actually in firing room 4 at the, I guess it's called the Launch Control Center too. I'll call it Launch Control Centers. I guess, historic Apollo/Shuttle control center right in front of the VIB. It's pretty amazing to be in there. We basically moved our consoles are pretty much just monitors and software, so we moved them over there, and we enjoying a great view to the pad. We integrated NASA operators within us, so we are. The team on the SpaceX side is pretty much the same size, but then we integrated NASA in preparation to the crew interface. So we had several missions where we trained that. It worked very well. I'm really looking forward to sit between Kirk and Steve there, and we also integrated NASA into the decision flow. So it's going to be a joint team launching this rocket and controlling Dragon on the way to the ISS.
And when do you hand off to Hawthorne? What's the milestone?
We typically hand off to Hawthorne. It's very similar right after separation. Hawthorne takes over. But it's interesting. These control rooms, you do what you do, and I often don't realize where I am. Except when I look up and I realize, oh, I'm actually in Florida, or I'm in Hawthorne. Yeah, I do the same job for almost every launch these days, and it's very I want to say it's very virtual. You just focus on what you see and what you hear on your headset.
Okay, so that's going to wrap things up here for today. For the media here at Kennedy Space Center, the NASA administrator will be joined by our NASA astronauts assigned to SpaceX missions. Tomorrow, they will be here at 4 p.m. to do a media Q&A. And our launch coverage for the SpaceX Demo-1 mission off of Pad 39A will begin at 2 a.m. for the 2:49 a.m. launch. To follow along with this mission, you can follow along at www.nasa.gov/commercial crew. And to follow along once it's attached to station, please follow along at www.nasa.gov/station. Thank you so much.